screen is visible for everyone? Hello? Hello? Yeah, today,
Yes, sir, it is visible.
today before going to a new topic, predicate logic. Actually, it is the second part of second unit. Okay, first full part is preposition logic. We have already completed, and I have given an assignment for you. I think most of the no one will do. I know that. I will complete this assignment within 10 minutes, and I'll go to new topic. Okay. Is it visible for everyone? This is the assignment I have given the last class. Look at here, please. Give me a minute, please. Let me take a pen. Here I have given 4 sentences. Yes1, yes2, yes3. Everyone has this problem with you? Yes4. Totally, we have 4 sentences. And we have to prove that these we have to prove. And we have to use these 3 methodologies. Okay, let me discuss one by one. What is the first statement? Mammals drink milk. Okay, are you getting me? Observe carefully. We have to get the inferences from these statements. Second statement is man is a mortal. Now third one is man is a mammal. Now can I have any inference from 1 and 3? 1 and 3 statements. From statement 1 and statement 3 we can infer that. Can anyone tell me what we can infer from this? In the first statement,
Man drinks milk.
yes, mammals drink milk, and now we can, wherever mammal is there, we can represent man. Now can I write like this? Man drinks milk. Yes, will you agree? If anyone will agree, now from statement 1 and 3 we can infer that man is a mammal. So now wherever the mammal is there, I can replace with man. Okay, man drinks milk. Now from 3 and 4, okay, from, look at here, what inference I can do from 2 and 4? Could you please tell me? From statements 2 and 4 I can infer that here I am saying that Tom is a man. Now I can easily say that Tom is a mortal. Everyone will agree? Hello? Yeah,
Yes,
from
sir.
the statements 2 and statement 4 we can infer that Tom is a mortal. Okay, now till now we got 2 inferences. Now from this what we have to prove is Tom drinks milk. Okay, then ultimately we should prove that Tom is a mortal. Okay, we will see how to prove it. Now for the provement of this 5 and 6 I'm going to use 3 mechanisms. First one is I'm going to use some clausal forms. This is also called as CNF. First understand the problem. Okay, then we can easily tackle it. Second one is I have to use inferences using modus ponens. Okay, modus ponens formula I have already given. Okay, are you getting me? P implies Q and Q. We will get Q. Okay. Third one is we should prove that using resolution. Okay. Now these are the 4 sentences they have given, and they asked us to prove Tom drinks milk and prove Tom is a mortal. Okay, these 2 we have to prove it. Now in order to prove 5 and 6, I can use 3 mechanisms, either by using CNF or by using modus ponens or by using resolution. Now we will go one by one. Now shall I move to next slide? I think everyone understood the problem. If not, you can, I have already posted in the WhatsApp group. Okay, you can open that PDF file. Okay, hello, I need response from you.
Yes, sir. Yes, sir. Yes.
Now what we have to do, we got sentences. Now we have to represent the sentences in the form of syntaxes. Now I can write that I already know that Tom is a mammal and he drinks. Later, if not, we will prove it later within 2 minutes. Okay, mammal drinks milk. Okay, here we know that Tom is a mammal. Okay, he is a man. Okay, man is a mortal. Okay, then here they have given that Tom drinks milk. Now we will say negation of this. We will see within 2 to 3 minutes. First, let me take mammal Tom drinks milk. Here Tom drinks milk. Infer it. In the same way, from second sentence, Tom is a mortal. Okay, are you getting me? If you consider, if there is no clear, you can consider Tom is a mammal or Tom is a mortal here. Okay. Now I can say that Tom is a mortal and man is a mammal. Okay. Now here, instead of taking Tom is a man, if you take Tom is a mortal, it is correct. Okay. You should take Tom is a mortal. Okay. Otherwise, we cannot get this inference. Okay. Tom is a mortal and we already told that man is a mortal. So can I call Tom as a mortal? Hello? You please consider it as Tom is a man, not a man. Tom is a mortal, you consider it, please. Okay. Hello? I need response from this.
Yes.
Yes, yes. Now let me erase it. From this, you don't write it as man. You please consider it as mortal. Okay. Now, if you say Tom is a mortal, okay, then otherwise we can infer like this: Tom is a man is a mortal. We can, without taking this also, we can infer it. Okay. So the first statement is okay for everyone. Tom is a man is already mortal. So we can infer that Tom is a mortal. So wherever Tom is there, we have already represented that Tom drinks milk, mammal drinks milk. So we can consider like this. Second statement is man is a mortal. Okay, we identified that man is a Tom. So we can infer that man is a mortal. Okay. Anyway, man is a, here man, we have only one person called it. It can be taken as Tom. Third statement is man is a mammal. Here man is Tom, we have already identified. Man is a mammal. Okay. Now, could you please tell me what kind of inference? Now, statement 1 we can represent it as P. Statement S2 we have represented as Q. Statement S3 we have represented as R. Fourth statement is Tom is a man. Directly we can write it as Tom is a man directly. Okay. From the fourth statement. Now, what we can do is, now the equations are PQ, the prepositions PQRS in the form of P implies Q, isn't it? Yes or no? All the three equations P, Q are in the form of P implies Q. Yes or no?
Yes, sir. Yes,
now,
sir.
if we want to represent CNF, first what we have to do? We have to convert negation P RQ. Can I write like this?
Yes, sir.
Yes, yes. Now, in the is it okay for this? Now, is it okay for this slide? Is okay for everyone? Can I move?
Yes, sir.
Yes, sir.
Yes. Now, here, what you should also prove that fifth statement. What is fifth statement? Tom drinks milk. We can write that. Okay. We already know that Tom is a mammal. We can write like this. Okay. Now, he drinks milk. Tom drinks milk. From fifth and sixth, we can infer like this. Now, this statement P can be written as P implies Q can be written as negation of mammal or drink milk. Is it okay? I have done it same for P, Q, R. Any doubts in this statement? It is simply P implies Q can be written as negation of P or Q, please. Okay. Any doubts in the statement 1 and statement 2 and statement 3?
No, sir.
Yes, yes. Now, what is my goal? My goal is, I have Tom drink milk. Previously, if I want to prove Tom drinks milk in resolution, what I have to take? I have to consider negation of the drink. Will you agree? I will take the negation of the drink and I will prove it as null. If I prove it as null, that means that Tom drinks milk. Will you agree for my statement? Hello?
Yes, sir.
Now, originally speaking, I have to prove Tom drinks milk, but instead of taking positive way, I am taking a negative way, because in resolution we will take the negative way and we will prove that it is null. If we prove that it is null, that means Tom drinks milk. Clear? Now, shall I move? This is the fourth statement. We already know that Tom is a man. Okay. Now, PQRS. I have four statements and I have to prove it as negation of the drink. Now, let me go to modus ponens. You can also go in this way. Now, resolution. Now, what I have to take? Negation of the drink. Could you please understand this carefully? What I have to consider? My goal is to prove drink Tom milk, and I wanted to disprove this negation of the drink Tom milk. So, which statement I have to consider? Now, I have my input is negation of the drink. Now, for that, what would be the better choice? Could you please tell me? Is it P? Is it Q? Is it R? Could you please tell me the choice, which statement I
sir.
have to, is it P? Here I have negation of drink, so I have drink. Can I take like this? Can I take this? So now I have taken P, negation of mammal and drink. Now this will be strike out with this. Now which will come down? Negation of mammal of Tom will come down. Now could you please hello? Hello?
Yes, sir.
Yes, there was a power problem. Just now I have given my mobile connection. Okay, now no issue, na? Shall I continue?
Yes, sir.
Yes, yes. Now, please give me 1 minute. There was a power problem still. Yes. What I wanted to prove is second state. Please give me a minute. Now we are here. Okay. Now negation of mammal. Okay. Now could you please tell me what statement I have to take for this? Now I'll go to previous slide. Where is the here? I have negation of mammal. I have to select mammal. Okay. Which one? Now shall I take R?
Yes, sir.
Hello. Earlier we have taken P. Okay. Now strike it out. Now I'll strike it out R. Now if I take R, now this negation of mammal and this mammal will strike out. And what will come down? Negation of man of Tom will come down. Is it okay? Clear?
Yes, sir.
Now what is the better choice for man of Tom? Please show me where is, yes. Is it yes? Yes. Now I will consider a statement. So man of Tom will strike out with man of Tom. Now we have disproved that null. So you can ask one question from this, sir. In the previous class, we have converted into CNF. Then only we have started the problem. Is it, if it is in your minds? Is it the question in your mind?
Yes, sir.
We can also convert. Actually speaking, officially speaking, you should convert every statement of PQRS into disjunction of literals. Then only you can apply the resolution. And this is, if you want to have very simple kind of statements, in this way also you can convert it. Is it okay? Now, for example, in the examination, if you have enough time, go with CNF and convert it. If you have very less time, for example, if you, this question got it for 10 marks, you go properly CNF and then do it. If you have a question for 5 marks, it is better you go with no need to apply these forms. Okay, if you apply De Morgan's laws, it will take another 2 steps. Okay, now you can also get resolution with this step also. Is it okay? For showing that, I have given this example. Is it okay?
Yes, sir.
Now in the examination, you please apply the mechanism depending upon the marks. If it for 10 marks, you apply the total CNF, then only you start resolution. Okay, and take the table and substitute anyone. Now if the question got for 5 marks, then you can, choice is in your hands. Okay, shall I move?
Yes, sir.
Yes, yes. Now let me tell you, remember Kerry, very, very important thing. What are the limitations of preposition logic, or what are the drawbacks of preposition logic? Okay, you should know this point. Then only we can enter into predicate logic. Okay, now before going to the predicate logic, first let me discuss some examples. Okay, why we cannot represent some logics in preposition. Now, for example, if you consider all dogs are faithful. Okay, please listen carefully. Don't take anything. Tommy is a dog, please. Here in the first instance, I'm saying that I'm saying it as generally speaking, all dogs are faithful. Okay, now specifically speaking, I'm taking here Tommy is a dog, please. Okay, now therefore, can I call Johnny is faithful? Hello. Now, could you please respond?
Yes, sir. You can.
Now, yes. Now, I can say that Johnny is faithful. If I have Jim, please. Jim is faithful. Can I call Jim is also a faithful? If I want to call Jim is a faithful, I don't have any prepositions with me. Can I call Jim as faithful? Yes or no?
No, sir.
Can I call? No, we cannot call. So we cannot represent specific areas with the help of. Now let me discuss another example. Now I will come back to this example after 5 minutes. Please, I'm going to tick mark here. I will come back. Now let me give some other examples. Okay. Here I'm calling all dogs are faithful as P. Is it visible for you? Tommy is a dog. I have considered this equation as Q. Is it visible?
Yes, sir.
Now I have combined these two statements, P and Q. Now can I call Tommy is faithful? Now I can combine here. If I combine all dogs are faithful in statement 1, here I call Tommy is a dog. I'm saying one dog is faithful. That doesn't mean that all dogs are faithful. Are you getting me? There will be a small problem between, now it will come as, now we will repute it. Okay. We cannot infer that this is preposition logic. Now let me discuss. I can say that Tommy is faithful, but not if I take Jim or if I take Jill or if I take XYZ. They are not faithful. Only Tommy is a dog and it is faithful. Okay. No. I cannot infer this rule for all the dogs. Now slowly move to next example, please. Okay. I will come back within 2 minutes, please. I have taken one more example. Tom is a hardworking student. Please observe carefully. I can write this as hardworking Tom. And Tom is intelligent student. I can write this sentence as Tom is intelligent. Now, if I combine these two statements, I can write that Tom is hardworking and Tom is intelligent. Are you getting me? I can write this combined two statement and I can infer that Tom score high marks. I can represent the sentence in the form of syntax. Hardworking Tom and Tom intelligent. So it implies that he can score high marks. Now let me go to another example, please. For example, here I can say that Tom is a dog. Yes. What about John, Jill, some X, Y, Z? Okay. All students who are hardworking and intelligent score high marks. Can I infer this statement in this way? Here I said that Tom is hardworking and Tom is intelligent. Then please give me 1 minute time. I will answer your questions, please. If you have any questions, you please keep them with you. I'll come back within 2 minutes, please. Can I write like this? Tom is hardworking and Tom is intelligent. Now, Tom score high marks. Can I write that all students who are hardworking and intelligent score high marks? Can I use this statement? Generally speaking, please now answer me.
Yes, sir.
Yes. Generally speaking, it is true. Universal truth. It is a universal truth. Please, no one will disagree. Now, understand carefully. Here, what I am representing is wherever there is a student, I am representing with X. Just look at carefully. For all X, same statement I am writing it as for all X. Now, X is a student. Okay, where X is a student. If X is intelligent and X is hardworking, then X score high marks. Can I interpret this statement in this way? Yes or no?
Yes, sir.
Yes. Now I need some discussion. Okay. Now within 2 minutes, we'll go to discussion. I can write. This is a general statement. It is a universal truth. It can be represented for X. Now, wherever X is there, I can put John. I can put Jim. I can put X, whatever it may be. Now, this will be applicable for all statements. Now, can I call this statement as a generalized statement? Yes or no?
Yes, sir.
Yes. Now, in programming languages also, we are going to use variables. Clear? Now, wherever X, I can use Jim. It can be John. It can be Jill, whatever it may be. Now, slowly, I'm introducing a new topic, please. Now, if you understand this slide, I'll go back to the previous 4 slides. Please observe carefully. In general, Preposition logic can deal with only finite number of prepositions. Okay. Now, if I want to apply, if there is only 3 dogs, Johnny, Jim, and Laika. For example, if I want to represent the same statement in preposition logic, Johnny is faithful, Jim is faithful, Laika is faithful. Now, if all dogs are faithful means I have to represent the same logic in by implication. I have to write that Tom is faithful and Johnny is faithful and Laika is faithful. That means preposition logic uses only for specific dog. It cannot be used for generalized purpose. Whereas universal, wherever in artificial intelligence, you cannot write logics for a specific purpose. You should write a logic for general purpose logic you should write. So slowly we are moving from preposition logic to the predicate logic. Predicate logic is also called as first order logic. Now, did you understand? Now, can I go back? Now, if I want to write the same thing in the form of preposition logic, I have to write for every specific dog. For example, if you represent 3 dogs, I have to represent everything with the help of and symbol. It has to be true. It has to be true. It has to be true. Are you getting me? Now, I'll go back to the wherever I have started. I will now. Now you answer my question. Everyone, please answer for my question. Here, all dogs are faithful. I am discussing only about Tom is a dog. Therefore, Johnny is faithful. Can I call in general tendency? Hello? It is only specific to Johnny. If you want to write logic only to the specific, then you can use preposition logic. Whereas, if you want to write a generalized logic, you cannot write in preposition logic. You should go for a new logic called as predicate or preposition logic. Observe carefully. Now, everyone, please look at here for 2 minutes, please. The first order logic is a predicate logic. Just now I told you that you can also call first order logic is also called as predicate logic. Okay, is a generalization of the preposition logic. Okay. Now, if you call preposition logic as a C language and first order logic has to be called as C++. Okay. Preposition logic is the subset of a first order logic. First order logic is a superset of preposition logic. Here we are going to write the logic for generalization principles we will write. We will not write logic for specific dog, okay, or specific person, okay. We will write a generalized logic, okay, that allows us to express and infer arguments in infinite models. Are you getting me? Now, remember carefully, in the previously, I told you that only for finite models. Here I told you that I can apply preposition logic only for finite models. Here somewhere I told you it is a finite model. Okay. Someone, could you please tell me where I have discussed it? In generally, a preposition logic deals with only finite number of prepositions. Finite number means it can be a Jim, it can be a Jill, it can be a Laika, or whatever it may be. So only a particular. It cannot be applicable for all students. It can be applicable for 1 or 2 students. Are you getting me? If a person X is studying well, if X is hardworking, X is intelligent, and he can, it generalizes speaking, it can be true, but specifically preposition logic. Now, if you want to make the same statement as generically, you should import in the same way. Wherever, if you want to make this statement as generalized, you should write like this. For all X, where X is a student, and if X is intelligent and hardworking, okay, then he will get high marks. Where X, you can use any person, Rama, Krishna, Sita, whatever it may be. Now, this is nothing but generalized logic. So, can I move slowly from preposition logic to the first order logic? Now, I will wait for here for 2 minutes. If you have any queries, I will answer for them, please. Hello. Now, did you understand my presentation? Now, first order logic of a preposition logic is generalized of preposition. Please observe carefully. First order logic deals with generalization of the preposition logic, and we can represent infinite number of models. Okay, are you getting me? Hello?
Yes, sir.
Yes. Now slowly shall I enter into first order logic?
Yes, sir.
Shall I
You can.
go? Yes. Now, thank you. I'll try to slowly introduce. Now, I think everyone understood what is the drawback of preposition logic, why we are moving from preposition to first order. Yes or no? You should go it. You should get it. Okay. How to represent to infer preposition logic. Now, first let me the basic terminology of first order logic. Okay. The syntax of first order logic consists of terms, predicates, and quantifiers. Please observe carefully. Today I will discuss the basics only. I will not. Tomorrow we will go for inference mechanisms. Okay, maybe tomorrow's class. Okay, shall I go? Now, what is a term? A term denotes some object other than true or false. Now, if you observe this statement carefully, most of the preposition logic, always we are going to represent truth values in the form of true or false. But here, a term denotes some object that other than true or false. Are you getting me? That is called as term. Now, Tommy is a dog. It is one term. All men are mortal. This can be called as terms. I am not calling them as sentences, please. Sentences terminology I used in preposition logic, please. Now, please observe carefully. In preposition logic, now we discussed that in preposition logic, the knowledge will be represented in the form of sentences. Every sentence is going to represent in the form of truth values, either true or false. Now you forget these kind of terminologies from now onwards. Now we are within the preposition, within the first order logic, we cannot use this terminology. Okay. Yes or no?
Yes, sir.
You should forget about what is sentence, what is preposition, what is true or false. Now, in new terminology you should remember for the next 2 to 3 classes. A term denotes an object which is not true or false. Please, earlier we discussed that a sentence is going to return either true or false. Okay, then what is a term? Anything is a term. In previous preposition logic we can discuss that anything is a sentence. Okay, now here you can represent constants and variables. Okay, first we will discuss what is a constant. Okay, now a constant is of type W. Okay, which is a name. Okay, that denotes a particular object of set. Now, for example, in Java you will call them as pi equal to final 3.14. in Java, final int equal to final float. Will you write the same thing in Java? Did Nagendra discuss same thing? Hello? How you are going to write constants in Java?
Using final variable.
Yes. Now in C++, I think Nagendra also discussed in C++.
We don't.
You don't have C++?
Yes, sir.
Okay. DS, you have completed data structures?
Yes, sir. In with C, sir.
Okay, very good. Sorry. In C++ means we are going to use constant. No need, just remember constant int some variable equal to value. Okay, that is now it is C++ notation. In C++ we will call it as constant. In Java we will call it as final. Okay, now a constant of type W is a name. Which is a name? Here you can give any name, pi or whatever it may be, any name that denotes an object with a set W. It can be as 5 or it can be as string constant. You may have integer constant, you may have string constants. Is it okay? This is everyone knows about it, so I'm not discussing much more about it. Now shall I go to variable? If you know any programming language, you know about constant. Now shall I move? Hello? Yes. Now we will discuss about what is a variable. Okay. A variable of type W is a name that can be denoted any element of set W. That can be, for example, look at carefully. X belongs to n denotes a natural number. Now, for example, 5, 10, 15, all these are natural numbers. Can anyone tell me what is the natural number range? Natural number range.
1 to infinity.
Yes, 1 to infinity. So 5 I can call it as a natural number, 10 I can rate it a natural number. Okay. Now earlier, if you want to represent constant, there we have only one value. Okay. Here you can have any value. Here the variable is x. It can be a 5, it can be a 10, it can be 20. Now here D denotes a name. It can be a Jim, it can be a Jill, it can be a Leica, whatever it may be. Is it okay? It is called as variable. Now terms can also be, functions can also be represented in the form of terms. Please look here. In the previous slide, I had told you that what is a term? A term is some sort of object other than true or false. It can be a constant, it can be a variable. Now I am introducing term as a function. Please observe carefully. Now I can call function as also a term. A functional term of arity. Arity nothing but arguments. Now every function has some number of arguments, and every function will return a value. Will you agree? For example, if I want to add two numbers, add off, you can take 3, 4. Here I am going to return integer. It is going to return as 7. Is it okay? Now a function of the term arity is a term in English which will give you the number of arguments. Arity is nothing but number of arguments here, which will take, this is input and this is output. Input is which take n objects of type W1 to Wn. Are you getting me? It can be W1, it can be W, and so on Wn. And it returns an object of type W. Okay. Whatever the type you will take here, the same type it is going to return. Here I have taken the type as W. The return type is also W. Is it okay? It is a function. Now, if yeah, please.
All or generalized.
Generalized?
No, sir. Usually in function, it is not necessary that if we take W, we'll return W.
Most of the cases, if I please, generally speaking, if my input number of arguments are integers, mostly my return type will be integer. If I take float, my return type will be float. If I take character, my return type will be, generally speaking. Okay, are you getting me? Mostly in first order logic, we will discuss about generally speaking. Okay, here also I told the generally. As a thumb rule, I am saying generally speaking. Are you getting me? Specifically means sometimes it depends upon the function type, the function what we are, maybe in C++, if you take integer and float, you can return float also. It may differ. Here I am discussing generally speaking. Okay, the term I used already, generally. Okay, generally if my integer type is W, my return type will be W. Are you getting me? Generally speaking, specifically means I may not agree with you. Okay, specifically means I will agree. Okay, here I am saying generally. Are you getting me? Here my function name is plus, this is nothing but my term, and these are my inputs, and the return type is 7. Both are, plus is my term, and these are constants. 3, 4 is a constant, 7 is a constant. Now could you please tell me, a term can be a constant, a term can be a variable, term can be a function. Will you agree till now?
Yes, sir.
Hello? Yes. Okay. Now I think I am going to close about what is term. Now slowly we will enter into what is predicate. I think no need to discuss about these functions now. What is function? I think everyone knows about what is a function. Okay. Hello?
Yes, sir. We know.
Yes. Slow. What is a predicate? Predicates are like functions. Please. Now I am coming to preposition logic. Predicates are like functions except that their return types is true or false. Now it is mostly equivalent to sentence of preposition logic. Is it okay? Now predicates are like functions, like they're not exactly functions. Their return types is true or false. Now can I call it is as equivalent to as a preposition logic, as sentence? Yes or no?
Yes, sir. You can
Yes. Now, yes. Just now I told that they are like functions. Please, they are like functions. For example, if you take a function as greater than, GT stands for greater than. Here I'm asking a condition x comma y. Does x is greater than y? Okay, is true. Okay, here this function predicates returns true or false, only truth values. If x is greater than y, then it will be returned true, else it will be false. Is it okay? Now, this predicate, is it returning true or not? If x is greater than y, is it returning true or not? Yes, it is returning true. Else it is y is returning false. Is it okay? Here, gt is a predicate symbol that takes two arguments of type natural number. Here I have to what is x and y. Here I had specified both x and y are natural numbers. Somewhere I had discussed it. Okay, then here I am. If 3, 4 is a valid predicate, as per this statement, now could you please answer for my point? GT 3, 4, is it a valid predicate?
Yes, sir.
Why it is yes? It is wrong.
No.
My condition, what condition I have given it is GT x comma y. My condition I have given it as if x is greater than y only, I have to take. Here 3 is greater than 4, yes or no?
No.
So I cannot call it as predicate. It has to satisfy my condition. My condition is gt x comma
Sir,
y.
it will return false na, sir.
One thing, please observe my condition. GT x comma y. Yes, please give me 1 minute. My condition is GT x comma y is true if x is greater than y. Now I am not taking 4 is greater than 3. I'm always seeing is it satisfying my condition. If it is satisfying, I will call it as predicate. If it is not satisfying, I will not call it as predicate. It is not valid predicate. Okay. Now,
Yes, sir.
please wait. I think you should get this point. Please observe this statement carefully. I should discuss this point then only. Now, let plus be a function. It takes two arguments and it returns a natural number. If can I take like this 2, 3? Is it a 2 or natural? 2 and 3 are natural numbers? Yes or no?
Yes, sir.
Yes, it will return 5. Can I call this function like this? Yes or no? It will return 10 and 10, 5, it will return 15. Yes or no?
Yes, sir.
Yes. Can I call like this? I can also. Now, if I give a like this, please, could you please tell me, is it a valid function or not? Plus 0, minus 1. Can I call this as valid function? Plus
No,
0. Huh? It is
No,
not. No, because minus 1 is not a natural number. Here I told you that my condition is if it is natural number, then only it will return. I told that it is my condition function should take only natural numbers. Here minus 1 is not a natural number, so it is not a valid format. Here 1.2, 3.1, is it a valid function of format? Not. It is not, because it is not a natural number. Are you getting me? First understand my condition. Here also I have given the condition like this. If I want to make greater than of x comma y, my condition is x should be greater than y. Then only I will call this as valid predicate. If not, I will call it as invalid predicate. Now, from this statement, can I call this as valid or invalid? Now, could you please tell me?
invalid, sir.
Yes, very good. Now, simply, I'm not going in depth. Okay, I'm not today. Don't go for inferences. Okay, I'm introducing what is terms, what is predicate. Anything is it okay? Now, terms are nothing but a constant and a variable and a function. Now, a predicate and one more point is functions doesn't return any true or false conditions. Terms doesn't return true or false, whereas predicate always returns true or false conditions. Now, will you agree till now?
Sir, if the predicate returns either true or false, is it valid?
Yes, it is valid. But
Then GT of 3, 4 is written in
based on the
false.
condition, it should satisfy the condition. Okay. Based on this condition, officially speaking, it is also called as predicate. Even though it
Sir,
may
if the
not.
condition is satisfied, it will always be true.
Yeah, that's it. That's what I'm saying. If the condition is satisfied, it is always true. If the condition is, if I don't have any condition, then you can call it as valid predicate. Clear? Always it depends upon the condition. Today, don't discuss anything.
Sir, I didn't get you.
Yeah, please.
Sir, I
Please.
didn't get you when you said if there is no condition, then it is called valid predicate.
No, one thing. Now, it is a function. GT is a function. What is the definition of a predicate? A predicate are like functions, except that their return types are true or false. Here, the return types are values. Either it can be integer, it can be float, it can be character in functions. Whereas here, predicates are also like functions, and they may not return integers, floats, characters. They will return only true or false. Okay. Here, this function returns only true when this condition satisfies. Are you getting me? Here, GT function is, I will call it as a predicate. So, it is satisfying two natural numbers. Two natural numbers, yes or no? Here I have given a condition. Here, if I call 3 minus 4, is it satisfying my condition or not? Hello? I am saying that it should satisfy a condition. I have given the condition as if the arguments are natural numbers, I will call it as valid predicate. Based on this statement, you please tell me, okay, don't assume your own conditions, okay. Based on this statement, I am saying that it is a valid predicate. Based on this statement, I am saying that it is invalid.
Sir,
please,
so
please.
you took a normal condition assuming for yourselves without anything as
no,
base.
one thing, I am not taking anything from myself. Today, I'm not discussing any inferences. I already told you inferences we'll discuss tomorrow. Today, I'm introducing what are the terminologies. That's it. Are you getting me? Tomorrow, we will discuss about the conditions. When the time comes, no one asks the questions. When the time comes, I ask so many, no one asks the questions. Here, today, I'm introducing the terminologies. Based on this knowledge, I'm saying that it is valid predicate. Here, if it is a plus 4, I will call it as valid based on this condition. And you are asking me that I'm taking my own assumptions. Am I inferencing anything? Inference mechanism, tomorrow we will discuss. Today, I told you that I'm introducing the terminologies. What is the difference between term and predicate? Based on that condition, I'm saying that it is valid. If you pass valid number of arguments, then it will become valid predicate. And you're asking me, you are questioning me. I am not going any inference mechanisms. Tomorrow I will go to inference mechanism. Then you can ask n number of questions. Here, today I'm introducing the terminology. That's it. Based on this terminology, here I have given the condition as the numbers arguments must be natural numbers. Is it a natural number? Now you please answer me.
No, sir.
No. He has to answer for this.
Sir, it is not about that. I just didn't understand because you said 3 and 4 is an invalid predicate in the past 10 minutes. That's why. Yes, sir. Yes, listen. So what happened is, just because you said based on this, here GT is a predicate symbol that takes two arguments of type natural numbers. You said it that was your condition. Based on that condition, you are saying 3 comma minus 4 is not a valid predicate. So I'm asking you whether you took on your own that only natural numbers has to be.
I took.
Yes, sir. That is the question I asked. Nothing much.
Yes, sir. This is here. I have taken my condition. Okay. Here I took the condition. To give you a basic understanding, this is my own assumption. Okay.
Yes, sir. I got it. That was the question I asked.
Yes. Okay. I didn't understand your question. Sorry. Now, can I write a generalized logic, please? As we already know that using first order logic, we can write generalization of the logic. Now, for example, if X is a man, then X is a mortal. Can I write like the statement in this way? Hello? Hello?
Yes.
Now here I am not representing any person. In preposition logic, we represented some Tom, Jill, Jim. Here I am not representing any person. Here we are representing generalization of the principle. X. Here X can be, you can place any person. It can be a Tom, it can be Jim, anything. Okay. Can I write this sentence into this syntax format using predicate logic? Can I write this statement?
Yes, sir.
Man of X. Now, whenever there is an n, then I can write it as mortal of X. Now, can I convert this syntax into implication into negation of man of X or mortal of X? Can I convert?
Yes, sir.
Yes. Now, this is one simple example about a predicate, a simple predicate. Now, another example, if n is a natural number, then n is either even or odd. Can I write this statement? This, I cannot call it a sentence. Sorry, it is a predicate. I cannot call it a sentence. Sorry, still I am getting the preposition logic sentence terminologies. Now you can call it as term. Now you cannot use sentence. It is a term. Okay. Now, can I convert this term into this? If n is a natural number, so n is a natural number. Now here we are, then it can be either even or odd. Okay. Now it can be either even number or odd number. It is a predicate. Can I write like this or not?
Yes, sir, you can.
Yes, very, very important thing is now slowly I'm introducing quantifiers. This is the thing we should learn in first order logic. The third syntax about first order logic is quantifiers. Very, very important thing is, please, there are two quantifiers supported by first order. FOL stands for first order logic, please. FOL means first order logic. Okay, then we have two symbols. Okay, like this for all. If you want to represent it for all, that is a universal quantifier. Okay, that means if all the elements are true, please understand carefully. If I have a box, in the class, if I have 5 elements, if all elements are true, then I am going to represent it as for all. Only for example, if I have 5 conditions, condition 1, condition 2, condition 3, condition 4, condition 5, that means if my predicate or my term is satisfying all conditions, I will write it as for all. Only 1 or 2 are satisfying, then I will write it as there exists. Clear? Did you understand the difference between universal quantifier and there exists? There exists will be written like this. Clear? There exists means only partial conditions, maybe 1 or 2 conditions or 2 terms satisfies the condition, then you will consider there exists symbol. It is called as existential quantifier, whereas for all is called as universal quantifier. Now I will wait for 1 minute. If there is any question, I will clear and I will move. Now, 3 things I have given in today's class. What are the 3? One by one. Hello? Let me erase the screen. Then, yeah. Could you please tell me what are the basic terminologies in first order logic?
Terms, predicates,
Yes.
quantifier.
I need 3 people. What you understand about what is term? You please tell me. Okay. 3 people, 3 different people. Okay. First, anyone about term?
Term is nothing but it is object nothing other than true or false.
Yes.
Like
any term is always true, other than true or false. Very good. And what are the different forms of terms?
constants and variables.
And in a third one is
Function.
function. Please. Now what is predicate?
Predicate is always true or false. Something
very
is
good.
written true or false.
Now you represent like predicate is like a function. Please. Predicate is like a function which always returns true or false. Is it okay? Yes or no? Now, some other one about what is quantifiers. What is a quantifier? Please. No one is there? I need response from you. Why I am not getting any response about quantifiers? What can be called as quantifiers?
For all there exists.
For example, if you want to represent all conditions, then you are going to use for all. Only a particular number of terms or conditions satisfy some number of out of none, not full. Okay, then we will represent a there exists. Is it okay? Now, these can be called as syntax or semantics for first order logic. Then slowly we will move to before going to the terminologies. I don't want to discuss these things now. Could you please take this example? How to represent the terms into first order logic. Please take this example. Earlier also in first order logic, we have converted sentences into syntaxes. Now we are taking terms and we are converting terms into syntaxes. Please make it fast. Mammals drink milk. Mammals drink milk. Man is a mortal. Man is a mammal. Tom is a man. You can represent them as first order logic in this way. Mammals. Here we are there is no specific, okay? For all x, mammals of x drinks milk. Here we will represent x can be any variable. Man is a mortal. For all x, man of x is a mortal. Man is a mammal. For all x, man of x, mammal of x. Man is a Tom. This we already know. This is nothing but simple sentence. Man of Tom. Once if you convert these sentences, slowly we will move to discuss some inferential logics in the next coming classes. Shall we discuss some examples with there exists?
Yes, sir.
Yes. First, you please complete it. Then I'll go to some examples about when to use for all and when to use there exists. Then tomorrow class we are going to do some examples. I have left one topic in unit number 1, that is forward chaining and backward chaining. In first order logic also you have forward chaining. Okay, so combinedly I will discuss some examples. Okay, if you look at the syllabus, I left forward chaining and backward chaining in preposition logic. The same topic you have also in first order logic, so I have not discussed it. Okay, combinedly I will discuss in before closing the second unit. I will discuss this topic: forward chaining, backward chaining using preposition logic, using first order logic. Completed?
Yes, sir.
Yes, please. Let me discuss one or two examples. Please. Here we are representing that all dogs are faithful. Please look at here. All dogs are faithful. Faithful of x. Faithful of x. X is faithful. Now, all dogs are faithful. Hello?
Yes, sir.
Yes, please. Here, what is my sentence? What is my predicate? It term. I cannot call it as, it is a term. Sorry, every time we are using the term sentence. Sorry. All dogs are faithful. Okay. Now, can I write the faithful of X as X is faithful? Can I write it as X is faithful? Now, hello. Here, all dogs. Can I write X is a dog? If I combine these two statements, directly I can write it as, here I am representing all dogs. So we can represent it as for all X. Okay. All dogs are faithful. Okay. If it happens, this will happen. So we can take implication. Dog of X equal to faithful of X. Now, you will be in frustration if you look at like this. Directly you can write this term as this one. Here we are representing all dogs are faithful, can be written as for all of X, dog of X implies faithful of X. It is a syntax. Hello? Here we are saying that all birds cannot fly. Here we have represented all of X and cannot, before here we have given cannot, so we have represented as negation. Don't take this one. Directly you take this sentence, the term into this way. Here all birds cannot fly. Here if you consider all birds can fly in this way, here I am representing a negation. So all birds cannot. So some birds can reply. Okay. So here I have represented it as universal rule, and here I am saying it negation. Negation means not all birds. Will you agree for this statement? I think I will get some contradiction about this. Can I write this term in this way? Yes or no?
Yes, sir.
That means you can also write using there exists. There exist of X. Are you getting me? You can write preposition, first order logic in hundreds of ways. Are you getting me? Preposition logic you can write only one way, but first order logic you can write hundreds of ways, like a program. Like a prime number program can be written in 27 number of ways. But whatever you way follow, everything is correct. But one logic will give you within 3 statements. Another logic will give you in 10 statements. Are you getting me? Now, is it okay? Now, wherever there is a R, I have to represent with for every, and wherever there is some or part, I can represent with there exists as, or I can write a universal rule and I can put negation. Are you getting me? Now, with this basic knowledge, today I'm going to close the class, and tomorrow we will continue the inferential mechanisms. Now, whoever having questions, tomorrow we will have a debate for those questions. Okay. What are the conditions? Why it is false? Why it is true? Tomorrow we will argue them. Okay. Now, till now, whatever we discussed about first order logic, if you have any doubts, you please ask me. Any doubts in introduction to first order logic?
No, sir.
If not, yeah, shall I leave? If any doubts, I will be here. Otherwise, we will leave. Okay. Thank you very much.